Hello, I'm Laura Bertola. I'm mostly interested in how we can use genomic data to get insight into biodiversity patterns and inform conservation management. So for my PhD, I worked on lions, for which we did population genomics and kind of classic phylogeography. And that ultimately led, or at least contributed to the IUCN reassessing the subspecies and making a new delineation for the lion. And although I really like lions, it's actually quite easy to see when you look at these different lineages that we identify in lions that when you look at other species with similar distribution and similar ecology, that we find similar lineages or maybe even subspecies there. So I became really intrigued by using a more comparative approach, moving away from a single species focus and actually looking at a more kind of community level, community scale biodiversity pattern. So after my PhD, I reached out to Dr. Mike Hickerson at City College, New York, and I got the opportunity to become involved in this project on the Atlantic forest in Brazil in close collaboration with Ana Carnaval and Carl McDonald. And in this project, we don't only focus on a more comparative approach. We have genomic rat-seq data for 30 taxa, including plants, amphibians, reptiles, birds, butterflies. But it also has a focus on another aspect which I'm really interested in, and that is looking at those parts of the genome that actually play a role in adaptation. So moving away from just assuming that you're looking at neutral population structure. So in order to do that, we use a number of environmental data layers, including remote sensing, including bioclims, including historical projections of bioclims. And we use these environmental data layers to look for correlations of environmental gradients with genomic variation. And we can compare what parts of the genome are flagged by these respective data layers. So for instance, for some species, historical climate might do a better job in describing the patterns that we see compared to present day climate. And ultimately, we're interested in a spatially explicit approach of looking at population genetic on the map, making a distinction between neutral and adaptive parts of the genome. So I think this fits really well in with both the spatial and the temporal scales challenges that have been identified here in the first RCN meeting, as well as integrating remote sensing with other data sources, in my case, especially genomics. So I'm really happy to be here and looking forward to discussions.